This thing doesn't run. Because 7 plus 3 is 10. Because I can't think. Because at some point today, I think my answer was 9 this morning. Yeah, of course. Okay. All right. So for the last two, you have 2 and 1, and then 4/3 and 2/3. Good. So yesterday we focused all on substitution. Substitution is when you solve for a variable and plug that expression into your other equation, get a numerical answer, and then take that number and plug it back in to your original, any 3, that one, this one, or that one, to get your second value. Today, we're going to use elimination. So yesterday we substituted in, today we're going to eliminate a variable and then work backwards to get an answer. So our goal today is to look at equations and say, oh, so like in number 4, elimination or substitution are nice for this problem. Elimination is nice because you have positive 2y and negative 2y. So they would have canceled, quote unquote, which is our elimination method. And you'd have had 2x plus x, which was 3x, equaling 4. And then divide both sides by 3, and you get 4/3. So you can use either method for any equation type. We just start to look at, okay, which one's easier one. So if you saw number 4 in your test, both are equally as easy because both are set up sort of for either method. And number 6, this one is set up to eliminate the x values. So it's set up that 3x and negative 3x are going to cancel each other. So what I'm going to do is use the elimination method to eliminate x by adding my expressions together. So I'm going to add the equation on top to the equation on bottom. So 3x minus 3x is 0x. Y minus 2y is negative y. And negative 9 plus 12 is 3. So I get y equals negative 3. Once you have one variable, you take that value and you plug it back in to either original equation. Doesn't matter. So you can plug into the top or the bottom, but this would be like 3x minus 3 equals negative 9. 3x equals, add 3 to both sides, so you get negative 6, or x equals negative 2. So my ordered pair or solution is negative 2, negative 3. If you were to graph them, that is the point of intersection. So when you graph those two lines, they would intersect at negative 2, negative 3. Okay, number 7. 7 is set up to eliminate your y values. So 7 is set up to eliminate y. So once again, we're just going to add these two equations together. So 3x plus 2x is 5x. Negative 2y plus y is 0. 14 plus 6 is 20. Divide both sides by 5, and you get x equals 4. Once again, you take that 4, plug it back in to either original, and solve for y. So you have 2 times 4 plus 2y equals 6. So you get 8 plus 2y equals 6. Subtract 8 from both sides, and you get 2y equals negative 2. Divide both sides by 2, and we get y equals negative 1. You can always quickly check yourself. So you could take the 4 and the negative 1 and plug them back in. So 3 times 4 is 12. Negative 1 times negative 2 is positive 2. 12 plus 2 is 14. And I get 14 equals 14. So again, if I choose to plug into the bottom equation to solve for my other variable, I could take both answers and plug them back into the original equation I didn't use, just to quickly check myself, because you should be able to plug x and y into either equation and it should be true. Does that make sense? Number 8. Number 8 is sort of set up to eliminate the x's, but the problem is 4x and 4x aren't additive inverses. So when I add them together, I'd get 8x. So instead of adding my equations together, number 3, we're going to subtract them. So you're going to subtract the bottom equation from the top, which is sort of like multiplying through a negative 1. So sometimes you guys used to multiply through a negative 1. Same thing. So 4x minus 4x is 0x. 9y minus 6y is 3y. And 1 minus a minus 2 becomes a positive 2, or 3. So we get y is equal to 1. Take that 1, plug it back into either equation, and solve for x. And you should get x equals negative 2. Good? Okay, let's try some of the ones on the back. So in the beginning, that's always kind of easy. You have it set up that it's like, okay, this one eliminates that one. We're good. Well, as the problems become more challenging, you have to now start to multiply both equations to eliminate one from the other. So here we have 2m and 3m, so they don't cancel. And we have 4n and 5n, so they don't cancel. So what we want to do is find the least common multiple between one of the variables. So you can either choose to eliminate m or n by finding their least common multiple. So the LCM of 2 and 3 would be 6. So I could multiply the top equation by 3, the bottom equation by -2, and set it up that we have 6m minus 6m. You could also do 4 and 5. Their LCM would be 20 though. So then you're multiplying by 5 and 4. So you always want to try to pick the numbers that are smaller. It's easier to multiply by 2 and 3 than 4 and 5. Yes?
Did you multiply by like a -2 on the bottom?
Yes. So you're going to multiply the top one by 2. And exactly, I would want to multiply the bottom one by -2 so that I could make them additive inverses. So that 3 goes to every term and the 2 goes to every term. So that's sometimes a mistake we make too. So 2 times 3 is 6m. 3 times 4 is 12n. And 3 times -4 is -12. -6m, -10n, and +6. Add them together. The n's cancel out. You get 2n equals -6, or n is equal to -3. Take that -3 and always plug it back into one of your original equations, not the one you multiplied by. So if you multiplied incorrectly, then you might catch your error. So we're going to plug -3 back in for n. So I have 2m plus -3 times 4 is -12 equals -4. 2m equals, adding 12 to the other side, I get 8. Dividing by 2, m is 4. Now again, 3 times 4 is 12. 5 times -3 is -15. 12 minus 15 is in fact -3. So I can plug in and check myself. Okay, number 10. So this time, maybe I choose to eliminate the y's just so we switch it up. You multiply the top by 2, so you get 6x plus 14y equals 30. I'd multiply the bottom by -7. So 5 times -7 is -35. 7 times 2 is -14y. And a negative times a negative is a positive 28. So -35 plus 6x is going to give you -29x. Your y's are going to eliminate, and then 30 and 28 gives you 58. Divide both sides by -29. And nicely enough, we get -2. Take that -2, plug it back in. So maybe I plug into the bottom. So I get -10 plus 2y equals -4. Adding 10 to both sides, I get 2y is equal to 6. And y is equal to 3. Go ahead and solve for the next one. So again, we can choose what we want to multiply by and eliminate our terms. So here, I only have to multiply the top by 2 to be able to eliminate it with the bottom. So 2 times -3 is going to give me -6x. 2 times 5 is going to give me positive 10y. And 2 times 6 is going to give me 12. So I eliminate my x. Then I also eliminate my y. And I get 0 equals 12. But does 0 equal 12? No. So that tells me that this graph has no solution. But if I get no solution for a system of equations, what does that tell me about those lines? They're parallel. Okay. In number 12, similarly, I can multiply the top by 2 to cancel out my x's. But this time I get 0 plus 0 equals 0. Does 0 equal 0? Yes. So instead of parallel lines and no solution, these are, yeah. So not conjoining, not perpendicular, coinciding. Yeah. Yeah, it starts with a C, right? So coinciding, which means we have infinitely many solutions. Let's multiply 13 by 2. So we get negative 6x again. Positive 10y equals 14. And same thing. 0 equals 0, therefore infinite. And just because my board is terrible at writing, get an arrow. Yes. Yeah. Okay. And then in this last example, nothing cancels like nicely, so we have to multiply the top, multiply the bottom, and this time you still need to multiply by a negative. Yep.
Can you you could divide. Like say you have like a negative 4x and negative 12. Could you divide?
Yes.
Yeah.
Yes. Okay. This one doesn't, I mean.
I know, but I'm just saying.
Well, if you divide by 3, you get a fraction, so you don't want to do that.
But as long as do you have to divide both equations, or can you just divide one?
You could just divide one.
Thank you.
I can't change that to 2. Okay, so you get 0 equals 2 or no solution. Homework's on the next page.